Okay, so very good morning to all the students to be present there. Hope you are all fine at your places. Now, today we will come with your another topic, or you can say that the continuation part of the control system. And in this, we have to discuss about the transfer function and the impulse response. Now, if you remember in the last lecture, we had discussed about the control system, and you see that the control system has the two main important things that is called as open loop control system as well as the closed loop control system. So if you go back to my previous video, so you can just get an idea that in case of an open loop system, what will happen, and in case of closed loop system, what will happen. Very most important thing that you must can understand in open loop as well as closed loop system is in case of open loop system, you can say that that system is not reliable, that system is less efficient. But if you talk about your closed loop control system, in that system your system will be more accurate and more efficient as compared to your open loop control system. Okay, इसके अलावा अगर आपको याद होगा in last lecture we are discussed about there are two types of signals available in control system. One is called as input signal and another is called as output signal. So the input signal is basically denoted by R of t, and your output signal is denoted by C of t, where R stands for your input and C stands for your output, and this T, that is a bracket T, is stands for time domain. But if you have to convert this time domain equation into the frequency domain equation, we are using basically the Laplace transform. And I had already tell you in details in the last lecture that when you convert your time domain equation into frequency domain equation, you have to take that equation's Laplace transform. So Laplace transform is nothing. It is basically a tool which can be used to convert your time domain equation into the frequency domain equation. And if you have to convert back from frequency domain equation to the time domain equation, we are using inverse Laplace transform. Okay. Now, in case of control system, we are basically using input as R of S and output as C of S, where this S stands for the equation will be in your frequency domain. So based upon that thing, we are discussed about what do you mean by this transfer function and impulse response, because once it is clear to you about the transfer function, so we can get easy to get the numerical solved on this control system. Okay, now as you see in case of a transfer function, what do you mean by this transfer function? So you can see that the mathematical indication of cause and effect relationship existing between input and output to make it decide transfer function of the given system. It is commonly used to characterize the input and the output relationship of the system. In short, if you see, I will tell you that what do you mean by this transfer function? Transfer function is nothing. It is basically equal to output upon input. Or you can say that transfer function is basically the ratio of output upon input. Okay. Now, so you can see this in figure number 3.1. You have a system. There is a system, and in this system, there is an input signal, there is an output signal, and in between this system parameter, you have the selections of the system parameters. Now you can see, if you see, your output is equal to effect of efficient system parameters on the selected input, and your output will be equal to input into effect of system parameter. So there are the one thing that is called as effect of system parameter is basically equal to output upon input. Okay, so in short, if I talk about your transfer function, सो आप लोगों को ध्यान में ये रखना है कि ट्रांसफर फंक्शन क्या है. ट्रांसफर फंक्शन एक रेशियो है आउटपुट सिग्नल की इनपुट सिग्नल के साथ. आई कैन अगेन रिपीट, ट्रांसफर फंक्शन मींस द रेशियो ऑफ आउटपुट सिग्नल to the input signal, but only one thing that you must kept in mind, that both the signals are in time domain. Okay, I will tell you one more thing, that if you recall your efficiency, the efficiency is also equal to the ratio of output upon input. So transfer function and efficiency is one of the same thing, that is both the term says it is the ratio of output upon the input, but only one difference is In case of efficiency, the equation will be in a time domain, but in case of you can say that frequency, in case of your transfer function, both the equations are in you can say that S domain. Okay, so I will tell you one important thing, that your transfer function is nothing, it is basically equal to output upon input in your time domain, but in case of transfer function, it is again the ratio of output upon input, but in frequency domain. Okay, just a minute, I will tell you what we have, the both the values of 2. Just a minute. Okay, can you see my screen now? Students, can you see my screen?
No, sir.
Yes, sir.
Is it visible now?
So,
Okay, so I will tell you about the transfer function. What do you mean by this transfer function? So if I talk about this transfer function is equal to, it is output upon input. Okay, the ratio of output signal upon input signal is basically known as transfer function. But if I talk about your efficiency, it is also equal to output upon input. That means you can say that is your transfer function, in short we can say that TF is equal to efficiency, because if you see on the top, you have transfer function is equal to the ratio of output upon input, and if you talk about efficiency, it will again equal to output upon input. So if you combine the equation number 1 or equation number 2, you can see that on both the equations, the right hand side we having the same value, that is output upon input, the ratio of output upon input. That means your transfer function is equal to efficiency. But no, transfer function is not equal to efficiency. The reason being, if I talk about transfer function, this transfer function means the frequency is in S domain, that is the signal is in S domain. But if you talk about efficiency, the signal will be in a time domain. Okay, so if you see here, the transfer function means it is a ratio of output when the signal is in S domain upon the signal input when the signal is in S domain. But on the other hand, if you talk about your efficiency means output in time domain as well as your input is in time domain. Okay, now if you combine these two equations, so you can say that your transfer function is not equal to your efficiency. Now is it clear to you students? देखा जाए तो ट्रांसफर फंक्शन की डेफिनेशन कहती है रेशियो ऑफ आउटपुट अपॉन इनपुट, एफिशिएंसी भी कहती है रेशियो ऑफ आउटपुट अपॉन इनपुट, और ट्रांसफर फंक्शन और एफिशिएंसी दोनों कभी भी बराबर नहीं हो सकती. द रीजन बीइंग, ट्रांसफर फंक्शन कहता है द रेशियो ऑफ आउटपुट अपॉन इनपुट व्हेन द सिग्नल इज इन फ्रीक्वेंसी डोमेन, एंड एफिशिएंसी सेज it is the ratio of output signal upon input signal when the signal is in time domain. And we have only the one tool, that tool is basically called as your Laplace transform. As you know, in case of Laplace transform, we can convert our time domain signal into frequency domain signal. कर सकते हैं नहीं कर सकते हैं? सो क्वेश्चन इज, जब हम लोग अपने किसी भी फंक्शन में लैप्लस ट्रांसफॉर्म लगाते हैं तो वो लैपलेस ट्रांसफॉर्म क्या करता है, लैपलेस ट्रांसफॉर्म हमारे टाइम डोमेन सिग्नल को फ्रीक्वेंसी डोमेन सिग्नल में कन्वर्ट करता है। सो यहां पर आप लोगों को ध्यान देने वाली बात ये है कि अगर आप लोग किसी भी फंक्शन का आउटपुट अपॉन इनपुट करते हो, रेशियो आउटपुट अपॉन रेशियो इनपुट करते हो, बट वो सिग्नल अगर टाइम डोमेन में है तो हम लोगों को उसकी एफिशिएंसी मिलेगी। बट अगर सेम सिग्नल में सबसे पहले अगर आप उसकी लैपलेस ट्रांसफॉर्म करते हो, और लैपलेस ट्रांसफॉर्म क्या करेगा, आपके टाइम डोमेन सिग्नल को फ्रीक्वेंसी डोमेन सिग्नल में कन्वर्ट करेगा, और कन्वर्जन करने के बाद अगर आप रेशियो लेते हो तब आप लोगों को क्या मिलेगा, दैट इज मिलेगा आपका, दैट इज कॉल्ड एज योर transfer function. Okay, now in control system we are always and always discussed about your frequency domain, or you can say that always and always we are discussed about the transfer function. Like if you remember in last lecture, I will tell you that in case of your control system, this r of t is basically equal to your input signal, isn't it? And your c of t is basically equal to your output signal. Okay, so if you talk about efficiency, this efficiency is equal to, just a minute, this efficiency is equal to your r of t divided by your c of t. Okay, but if you talk about here the transfer function, so this transfer function is equal to r of s divided by your c of s. Okay, so here there is a difference between the efficiency as well as your transfer function. So हमेशा ध्यान रखिएगा जब भी हम लोग कंट्रोल सिस्टम डिस्कस करेंगे तो कंट्रोल सिस्टम में हम अपने सिस्टम पे हमेशा एस के साथ डिनोट करेंगे। दैट मींस हमारे जो सिग्नल्स वहां प्रेजेंट होते हैं वो सारे के सारे सिग्नल्स हमारे किस में होंगे, फ्रीक्वेंसी डोमेन में होंगे। Okay, now I think it is clear to you all the students to be present there, that is what is the difference between a time domain equation as well as a frequency domain equation, or what is the difference between efficiency as well as your transfer function. Is it clear?
Yes, sir.
Okay, now see, these are the, this is the example. Here you can see that some important terminologies used in related to the transfer function, as the transfer function is ratio of Laplace of output to the Laplace of input, and hence it can be expressed as a ratio of polynomial, that is transfer function is equal to p of s upon q of s. So here he can take a signal as p of s and another signal will be as q of s. So right here he can write down that a transfer function is nothing, it is basically equal to the ratio of output upon input, that is the ratio of ts is equal to ps upon qs. So this to be, you have to be just chalk it out, you have to remember it out, that how you can convert our time domain equation into a frequency domain equation. Okay, so these are all you are discussed in your previous course, that is in network analysis. Here you can see that how you can calculate the value of how you can calculate the value of frequency domain equation from the time domain equation. If you remember in third semester you were discussed about लैपलेस ट्रांसफॉर्म, आप लोगों ने मैथमेटिक्स में लैपलेस ट्रांसफॉर्म किया है, आप लोगों ने नेटवर्क एनालिसिस में या इवन आप लोगों ने मैथमेटिक्स में लैपलेस ट्रांसफॉर्म यूनिट्स पढ़े थे। तो उस यूनिट्स में आप लोगों ने देखा था कि जब हम लोग अपने टाइम डोमेन इक्वेशन को फ्रीक्वेंसी डोमेन इक्वेशन में कन्वर्ट करते हैं तो वहां पर हम लोग बेसिकली क्या यूज करते हैं, लैपलेस ट्रांसफॉर्म। सो जब भी आप अपनी लैपलेस ट्रांसफॉर्म यूज करते हो तो वो लैपलेस ट्रांसफॉर्म आपके टाइम डोमेन इक्वेशन को फ्रीक्वेंसी डोमेन इक्वेशन में कन्वर्ट कर लेता है। और यहाँ पर ये जस्ट वही फ्यू एग्जांपल्स दी गई हैं आपको, सो दैट यू कैन जस्ट गेट एन आइडिया दैट हाउ यू कैन कन्वर्ट योर टाइम डोमेन इक्वेशन इनटू योर फ्रीक्वेंसी डोमेन इक्वेशन। ओके, सो इट इज जस्ट एन आइडिया फॉर योर पॉइंट ऑफ व्यू दैट how you can convert your time domain equation into the frequency domain equation. Okay, now
Yes.
one of the most important thing that you must understand in case of electrical point of view, that you all know in case of electrical you have the three elements to be present there. In our whole of the electrical engineering we are having a three elements, and these three elements are nothing, it is basically the resistance, it is inductance, or it is a capacitance. So you can see here in table number 3.1 you can see that the first column is basically the elements that in electrical engineering, and there are three types of elements to be present there. We have resistance R, we have inductance L, and we have capacitance C. So if you talk about the time domain expression for the voltage, means what is the voltage across inductor, what is the voltage across capacitor, and what is the voltage across resistor. You can get a formula that in case of a resistor, your V is equal to I into R, but here you are expressed your equation in time domain. So instead of IR, you are using I of t. That t stands for, it is a time domain equation. So you can see that the second column, it is time domain expression for the voltage, and here it is write down that voltage across resistor is equal to R into I of t. The similar end, the voltage across inductor, that is equals to L di by dt, and in case of capacitance, that is equals to 1 upon C integral it dt. Okay, these are all we have discussed in our previous course in network analysis. That is, what is the voltage across inductor, what is the voltage across capacitor, and what is the voltage across resistor. So in case of voltage across resistor, we know by using the formula Ohm's law, V is equal to IR. So instead of I, we are using a time domain equation. So I is must be replaced by I of t, and inductor, that is L di by dt, and capacitor 1 upon C integral it dt. Now what will happen? The second column represents the time domain equation of the voltages of all the elements. And by using Laplace transform, what we have to do, we have to convert your time domain equation into the frequency domain equation. So simply what we have to do, we are basically using the Laplace transform technique, and this Laplace transform technique is converting your time domain equation into the frequency domain equation. So the voltage across resistor, voltage across capacitor, voltage across inductor will be shown in the column number 3, and you can see that the voltage across resistor, whereas it is in the second column time domain equation, it is I of t into R, but in case of third column, it is will be equals to Is into R. The reason being, I had already tell you that Laplace transform converts your time domain equation into frequency domain equation. So when you get a Laplace of your column number 2, you can get a column number 3, that is I of t into R is equal to Is into R. L di by dt is equal to SLS Is, and 1 upon C integral it dt is equal to 1 upon Cs into I of S. Okay, so in short, if you see that if you replace this I of S, this I of S is basically shows your Laplace behavior. So what will happen? In case of resistor, it will be treated as R, but in case of inductor, L will be treated as Ls, and in case of capacitor, it will be seen that it will be replaced by 1 upon S. So if you overall review of this table 3.1, you can see that after taking the Laplace transform of time domain equation and neglecting the initial conditions means you have already discussed in the network analysis, there are two type of initial conditions occur in inductor and capacitor. That in case of inductor, it will be treated as a short circuit, and you have to calculate the current through the short circuit. And in case of capacitor, you will treat it the capacitor as open circuit, and you have to calculate the voltage across open circuit. Now in case of inductor, when you treat it as a short circuit, the current through short circuit equal to 0, and in case of a capacitor, when you treated it as open circuit, the voltage across capacitor is equal to 0. So here it can write it down that if you take a Laplace transform of your time domain equation and neglecting the initial conditions, your resistor will behave as resistor, the inductor will replace as SN, and the capacitors will replace as 1 upon SC, and all the time domain functions get converted into the Laplace domain equation, that is I of t is equal to I of S, V of t is equal to V of S, and so on. Okay, so by applying these formulas, you can consider this one of the circuit as shown in the figure. So this is the one of the circuit. Here you can see you have two elements, that is R1 and L. And in addition to that thing, there are two more elements, that is R2 and C are connected in such a way that EI of t is the input voltage, and E of t or not is equal to your output voltage. So you see that we have converting this time domain equation into the frequency domain equation by applying the Laplace transform. So you can see that R1 will be replaced by R1, R2 will be replaced by R2, L will be replaced by SL, and the C will be replaced by 1 upon SC. And EI of t is replaced by EI of S, and E of t is equal to replaced by E of S. So we are converting our time domain electrical circuit into the frequency domain electrical circuit, or time domain electrical circuit into S domain electrical circuit by converting all the values. and when you convert all the values, your circuit will something like this thing. That is, EI of S is equal to R1. Instead of inductor L, it will be replaced as a SL, and we have R2, and we have 1 upon S2. So if you get the transfer function of this function, so this it is nothing, it is basically equal to the ratio of E naught of S upon EI of S. Whatever the value will become, this value is basically equal to the transfer function. Okay, now I think you can get an idea that how you can convert your time domain equation into the frequency domain equation. Is it clear to all of you?
Yes, sir.
Okay, so these are certain, you can say that the numericals, or these are certain formulas that you can use in our how you can get a transfer function from one signal to the another signal. So most of the numericals you are discussed in your previous subject, that is network analysis, that you remember that in case of network analysis, I will teach you the concept of pole and zero, that what do you mean by these poles, what do you mean by these zeros, what are characteristic equation. So all the cover cup that is you are discussed in your pole and zero, you are discussed in our time domain equation, the frequency domain equation, and in all that equation you are finally get your
यस सर मैं यस सर मेरा इशू आया स्क्रीन, मुझे स्क्रीन विजिबल नहीं है सर.
No
मैं
issue.
डिस्कनेक्ट करूंगा फिर.
I will share you. You have a network problem with you. I will share you the recording of this lecture after the class. You can go through that video also. Okay.
Okay sir.
So I will tell you that these all topic, that is the Laplace transform, the transfer function, the pole and zero, the electrical circuit, you are all discussed in your previous chapter, in the previous course subject, that is called as network analysis. And in case of network analysis, you got an idea that how you can get the value of transfer function. Okay, now in this semester or in this control system, you are least bothered about that how you can calculate the value of the transfer function, how this value will come. In that case, you have to apply this transfer function in your control system. Okay, so in the coming days when we start our next unit, and that next unit will be something like called as block diagram representation, you have signal flow analysis, you have mathematical modeling. So in all the cases, what we have, you all are having a figure, you are all having a certain problem. In that certain problem, you are given the transfer function, and based upon that transfer function, you have to analyze the system. Okay, so I will again repeat you that क्या है कि आप लोगों को ट्रांसफर फंक्शन कैसे कैलकुलेट करना है, या आप लोगों ने ट्रांसफर फंक्शन को कैसे कैलकुलेट किया है किसी भी टाइम डोमेन इक्वेशन को आप फ्रीक्वेंसी डोमेन इक्वेशन में बाय अप्लाइंग लैप्लेस ट्रांसफॉर्म कैसे करते हैं, ये सारा आप लोगों ने पीछे नेटवर्क एनालिसिस में डिस्कस कर लिया हुआ है. बट यहां पर कंट्रोल सिस्टम में आपको ये चीजें कैलकुलेट नहीं करनी है कि ट्रांसफर फंक्शन कैसे कैलकुलेट करना है. यहां पर आपको ये आइडिया होना चाहिए कि ट्रांसफर फंक्शन होता क्या है. और जब आने वाले टाइम पर मैं आप लोगों के साथ इसके अगले चैप्टर डिस्कस करूंगा, लाइक ब्लॉक डायग्राम, लाइक सिग्नल फ्लो, लाइक मैथमेटिकल मॉडलिंग, तो वहां पर क्या है कि आपको ऑलरेडी ट्रांसफर फंक्शन गिवन होगा कि इस सिस्टम का, इस प्रॉब्लम का, इस गिवन इक्वेशन का आपका ट्रांसफर फंक्शन ये है, एंड आप लोगों को उस ट्रांसफर फंक्शन को देख के सिस्टम को एनालिसिस करना है. ठीक है, सो यहां पर आप लोगों को ये मतलब जस्ट एन आइडिया है कि ट्रांसफर फंक्शन होता क्या है. ये आज के लेक्चर में सिर्फ आपको ये आइडिया था कि ट्रांसफर फंक्शन होता क्या है. और ये जो आपका चैप्टर नंबर 3 है आपकी बुक में, दैट इज यूए बख्शी की बुक में, इट जस्ट गॉट एन आइडिया दैट हाउ यू कैन कैलकुलेट द ट्रांसफर फंक्शन. आप अपना ट्रांसफर फंक्शन कैलकुलेट करते कैसे हो. बट इन एक्चुअल कंट्रोल सिस्टम आपको ऑलरेडी ट्रांसफर फंक्शन गिवन होगा, और आप लोग उस ट्रांसफर फंक्शन के लेके उसका एनालिसिस करोगे. और एनालिसिस करने के लिए वी हैव डिफरेंट टाइप ऑफ टूल्स, दैट इज कॉल्ड एज ब्लॉक डायग्राम रिडक्शन टेक्निक, we have signal flow analysis, and for solving the signal flow analysis we have Meson gain formula, and after that you have a mathematical modeling where we are using a derivative equations, double derivative, triple derivative equation. So we are using a derivative equation, and you can see that how you can calculate your system analysis and how you can calculate basically overall the transfer function. Okay, I think you can got an idea for today's lecture that what do you mean by this transfer function. Now anybody having any doubt, he or she can ask me now. Is it clear?
Yes sir.
Okay, fine. So this is all about for today's lecture. We will meet on tomorrow at our next lecture and start continuing this part. Next lecture we are discussed about another continuation part of this control system. Okay, so this is all about for today's lecture.
Excuse me, sir.
Yeah.
सर हमने कुछ सर सोचा था मिनी प्रोजेक्ट के रिलेटेड जीवन ने.
Just a minute. I will discuss with you. Just a minute. Okay. First of
Yes,
all,
yes, sir. Yes, sir. No issue.
first of all, we can see the attendance point of view. After that, we will discuss your minor project. Okay. So I think today those are absent. Roll number 1 is present. Roll number 2, 3. Roll number 4. Roll number 5 is present. Roll number 6 is absent. Then 7 is absent. 8 is present. Roll number 9 is present, absent. And roll number 10 is present, 11 is 12. Okay, fine. So I think there are only 3 students will be absent, and these 3 are 6, 9, and 7. 6, 7, 9 are absent. Okay. 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 Now tell me, Rusanshu.
जी सर एक्चुअली